Okay, these are questions from section 9.2 on solving single-step inequalities. The first question says negative 15x is less than or equal to 90. And it says, what process would you use to solve this inequality? Well, if it was something like this, if it was negative 15x is equal to 30, to keep it a little bit easier, I would have divided both sides by negative 15, and I would have solved x equals negative 2 on an easier question. When they are inequalities, the process is still the same. You're going to divide both sides by negative 15. But the rule is whenever you multiply or divide both sides of an equation or an inequality, excuse me, by a negative value, you must flip the sign in order for it to be true, which will be all values greater than or equal to negative 6 for the x value will make this true. So it says, what process would you use? You would divide both sides by negative 15, and you would flip the sign. Question 4 on your sheet says, represent these on a number line. So the first one says 6 multiplied by a number is equal to 18. And this is a question you would have gotten probably in grade 7. You would divide both sides by 6, and x would equal 3. Represent your solution on a number line, 2, 3, and 4. The value of x is 3, so it's a closed boundary point with no ray extending left or right. However, in the second example, all values multiplied by 6 are greater than or equal to 18. Same process for isolating for x. The only difference is all values greater than or equal to 3 is your solution. So on my number line, if I put my closed boundary point, all values greater than or equal to 3 means that any number from 3 outwards are values that are true in the inequality 6 multiplied by a number is greater than or equal to 18. Any value greater than 3 or 3 itself will work. Okay, question number 5 says solve each inequality. So all values less 7, when you subtract 7 from it, will have a value greater than or equal to 22. In order to figure out what values of x there are, we're going to isolate by adding 7 to get rid of the constant. And all values greater than or equal to 29 is correct. Any value greater than or equal to 29. It says you don't have to do a number line for these, so if you did, that's great. Now the next one, what I would like you to do is when you have your variable on the other side, read it backwards. So I'm going to start with all numbers plus 11 is greater than 4. So as I read it backwards, any value of x that you add 11 to is going to be greater than 4. You could also read it 4 is less than the value of x plus 11, but it's easier to read it backwards. Because once you do that, when you subtract 11 from both sides, any value greater than negative 7 will be true. Okay, so any value greater than negative 7, if I was to put it on a number line, open boundary point, and any value greater than that would be this way here. In your next question, get rid of your constant by subtracting 8.6 from both sides, and any value greater than negative 13.8 will be solution. And your last question, Ryan, if you subtract 65 from both sides, any value greater than or equal to 35 will make the solution true. Okay, here's questions 7a and d as well as 6a and d as well. So 6 multiplied by the value, when you multiply any value by 6, you have a value that's greater than or equal to 54. In order to figure out the infinite values that it can be, divide both sides by 6. Now some people think you have to you flip your sign. You only flip your sign if you multiply or divide by negative values, and that will be 9. So any value that is greater than or equal to 9 will make that inequality of 6y is greater than 54 true. In the second question of that, if you divide both sides by negative 1.6, you get y. You must flip your sign because you multiplied or divided by a negative value. Take your calculator. 10 divided by 1.6 is 6.25. So negative divided by negative is positive. So any value that's greater than 6.25 would make that inequality true. Next question, simple. Multiply both sides by 5 to isolate. And x will be any value that's greater than 150. And finally, I'm going to divide by negative 1/6 and divide by negative 1/6. X, flip my sign and figure out what 5, change to multiplication by the reciprocal. 5 multiplied by the reciprocal of negative 1/5 is negative 30. And any value greater than negative 130 will make that true. For question 9, it gives you an inequality statement right here. And then it asks you in both questions, is the value of x in the first one negative 12, and is the value of x in the second one negative 3? So in both cases, I'm going to solve first. I can do it one of two ways. I could technically solve both of these statements by adding 2.5 to both sides. That's one way I could do it. And if x is less than or equal to 12.5, is x a possible value? Is 12 a possible value that makes this statement true? So is 12 less than or equal to 12.5? The answer is yes. Another way I could have done that, instead of isolating, is I could have taken my equation and substituted 12 in. And if I substitute it and solved it, and if it's true, if 9.5 is less than or equal to 10, then it would be true. So if I do that same method for the second one, if I substitute x for negative 3, is 12 less than 20? Yes, it is. So therefore, x can be negative 3. Okay.